Hi, this is Pucho. Today we will be graphing the perpendicular bisectors of segments, and we will be writing the equations of perpendicular bisectors of lines. This is a great problem because it lets us review the important concepts of midpoint, slope, slopes of perpendicular lines, and writing the equations of lines in point-slope form. This is also an excellent problem because it gives us confidence in working with math. So let's read and just think about what this problem is asking. We want to write an equation in point-slope form for the perpendicular bisector of a segment with these endpoints. And the endpoints are m, -5, 4, and n, 1, -2. Feel free to pause at any time to write down the problem. So what we want to do is we want to write an equation of a line, but we want to write the equation of a line that is the perpendicular bisector of this segment that's given. The two endpoints are given on the segment. So what I'm going to do for graphing, and you'll see later that you really don't need to graph this problem to solve it, but this is a great problem to look at the graph and see what are we really doing. So I'm going to graph this segment MN with the given endpoints, and I'm just going to plot those points. M is -5, 4. I'm going to label that. And N is 1, -2. 1, -2. Now I'm just going to come on over here and draw the segment. Okay, so we have a segment here, but really, what do we want to do? We want to write an equation of a line, but we don't want to write an equation of this line. We want to write an equation of a line that is the perpendicular bisector of this line. Now, in order to write an equation of a line in point-slope form, we know that the great information to have to write a line in point-slope form is the point and the slope. So we're going to have a line that is a perpendicular bisector, but we need a point on that line, and we also need the slope of that line. So as I said earlier, this is an excellent problem for reviewing all of the things that we need to get us that equation of the line, including midpoint, slope, slopes of perpendicular lines, and all of that. So first of all, I want to find the middle. I want to find where would the bisector be cutting this line into two. And in order to get the middle point, or the midpoint, then we're going to use the midpoint formula. So the first step in doing this problem is to find the midpoint of that segment. So I'm just going to write midpoint. And then I'm going to come on over here and I'm going to take the average of the x's and the average of the y's. So I'm going to say -5 plus 1. Remember, we did this last semester. And that's my x coordinate of my midpoint. And my y coordinate of my midpoint is 4 plus a -2, or 4 minus 2 over 2. And I can easily get that midpoint. -5 plus 1 is -4 over 2, which is a -2. And 4 minus 2 is 2 over 2, which is 1. So if I drew this nice and accurately on graph paper, I can see that my midpoint Oh, let's just call it P is negative 2, 1. So here's a point that I need. P is negative 2, 1. And it looks like that is the midpoint. It just worked out nicely. Negative 2, 1. So I've got a point on that perpendicular bisector. Now, I know that the perpendicular bisector is a perpendicular line through the midpoint because it is a bisector of that segment. I'm just going to kind of sketch it right now. What I did was I just sketched or drew a line that I think looks perpendicular to that line. I'm not sure if I did it perfectly, but what I want to do is say, okay, to write an equation of a line, I need the point and I need the slope of that line. Well, I don't know the slope of this line because I only have one point on this line. However, can I get the slope of this segment and then use what I know about the slopes of perpendicular lines to get the slope of the perpendicular bisector? Can I do that? So let's see. I'm going to find the slope of my segment. And because I have 2 points on the segment, I can find the slope of my segment. This is an MN. The slope of MN is, and I can use the slope formula, y2 minus y1 over x2 minus x1. But because I already know the formula, I don't even need to write it down. The change in the y over the change in the x's. And also because we graphed it, we could do rise over run. But if you didn't have the graph, you would want to use the slope formula. So let's just do that. And I'm just going to do, because I'm used to doing slope, I'm going to say 4 minus a negative 2. So I'm just going to say 4 plus 2 over negative 5. Remember, I started with this 4, so I have to continue with the x's starting with this x. Negative 5 minus 1. Negative 5 minus 1. And we find that that slope is 4 plus 2 over negative 5 minus 1, and that is a 6 over negative 6, and the slope of MN is a negative 1. I'm going to put a little circle around the slope of MN, and I'm going to circle my midpoint. Now, I'm just going to put a little arrow, because my midpoint, this point, is on the perpendicular bisector, so I can use this one. But can I use the slope of MN if I want to write the equation of the perpendicular bisector? No. Now, I have to find the opposite reciprocal of the slope of MN, because the perpendicular line for which I want to write the equation has to be a slope that is perpendicular to the slope of MN. Do you remember from last semester how to find the slope of a line that is perpendicular to another line? Well, we remember that that is the opposite reciprocal. So I like to say flip it and change the sign. So this would be negative 1 over 1. If I flipped it, it would be 1 over negative 1, but I'm going to change the sign. So I'm going to say the slope of a perpendicular line to MN is a positive 1. Now this is the slope that I can use to write an equation in point-slope form. Guess what? We're almost done. We have a point on the perpendicular bisector, and we have the slope of the perpendicular bisector. And now we can write an equation of the perpendicular bisector in point-slope form. So let's do that. We remember, we know this formula, we're going to use it all the way through AP Calculus, and we're going to do that formula right now. Point-slope form. Great formula to know and memorize, use in many situations. Y minus y1 equals m times x minus x1. Well, here's my x1 and my y1, and since we're so used to working with these, I'm going to take a couple of little shortcuts, and here's my slope. So I'm going to say y minus y1 is 1 equals 1, which is the slope, x minus a negative 2. I'm just going to put plus 2. And there you have it, the slope of a perpendicular line to the given segment. Now you try this one. Can you write an equation in point-slope form for the perpendicular bisector of the segment with these endpoints? And try to do this one without graphing. Can you do that? We'll check it in class.
Perpendicular bisectors are cool, Dave. That's because you have confidence, Pucho.